Okay, in this video we're going to talk about this kind of function like square function, reciprocal function, square root function. Okay, so reciprocal function, what would be a reciprocal function according to you? I mean, if you are looking at any real number x, then the reciprocal of it would be 1 by x, right? So a function that would associate a real number x, okay, that associates a real number, any real number x with its, reciprocal 1 by x to its reciprocal, to its own reciprocal, that is 1 by x. Okay, so if x is 2, then 1 by 2, and so on and so forth. So that sort of a function would be called the reciprocal function. That sort of a function is called the reciprocal function, where fx equals to 1 by x. Now fx is equal to 1 by x, that means it is not defined at x equals to 0, right? So this function will not be defined at x equals to 0. That means the domain cannot take 0, right? Domain cannot take 0 in it. So it is a function from r minus 0 to r, fx equals to 1 by x. Okay, so let's now look at what this function would actually look like graphically. Okay, what will this function look? Yeah, before that, let's talk about the range. Range would be the complete R, right? Range can be complete R apart from 0. The range will also not contain 0. So the domain and range both will not contain 0 in it, right? So let's see what it would exactly look like. The function will look like, let's make our axis. So we have both the axes here. So 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, and so on for the y-axis as well. Okay, I'm not writing numbers out there, but you understand what exactly it is. So 1 by x. Okay, so let us give some x value. So x is 1, that would mean that 1 by x is 1, right? So at 1, 1 is the point. And then what happens when x is 2? Fx is actually 1 by 2. So y is 1 by 2. So it is becoming smaller. Okay, so 1, so 2, 1 by 2. Okay, similarly when x is 3, again 1 by 3, even smaller. So this will start shrinking. This will start shrinking. Okay, the reciprocal starts shrinking. When it is half, when x is half, y is actually 2. When x is half, y is actually 2. So that's how asymptotically the graph would go asymptotically like this. The graph would go asymptotically like this. So x values, and similarly, for the negative side of x. So when your x's are negative, of course your y's will also become negative, right? So the same kind of reflection you will get on the third quadrant as well. Okay, so the first quadrant and the third quadrant are like mirror images. Okay, mirror image of the first quadrant. So that's what is a reciprocal function, and that's what it looks like. It looks like asymptotes on the first quadrant and third quadrant. Next function that I would like to talk about is the square root function. What happens to root x? The square root. for any real number x, what happens to root x, the square root function? Now, so essentially, the function would be, square root function would essentially be a function that would associate a real number x to root x, positive root x. Okay, so it associates any real number x to positive root x. So root x, of course, is real for all x greater than or equal to 0. So root x, when is root x real? Root x is real for only all x greater than or equal to 0. So what will be the domain? The domain will be R plus. It has to be greater than or equal to 0. Okay, you cannot take square root of a negative function. Okay, you cannot take square root of a negative function and what comes out is also positive. So plus root x is the function. So what will be the range? So domain, we have said that R plus is the domain. So what will be the range? Now the range will also, of course, be R plus. The square root of 0 is 0 and all the positives, right? So it will be 0 to infinity closed at 0, 0 included. Now, what do we observe? So your domain is equal to the range out here. And what do we observe? We observe one peculiar thing out here, that root x will be increasing for any increasing x. Okay, so as x increases, root x, whatever comes out of the root will also increase, right? Root 2 will be smaller than root 3, right? So, or the other way around, root 3 will be greater than root 2, and so on and so forth. So, as x increases, what happens to root x? It also increases, okay? I mean, simple example, root 1, root 2, and so on and so forth. So what will this function on the graph look like? What will this function on the graph actually look like? Let me make a graph for it. Just notice one thing, the domain and range both are R plus. So actually what would be required for us is actually just the first quadrant where both the axes are positive. X as well as y both are positive there. So 1, 2, 3, 0. 0 is included, right? So 0 is a very important point here. 0, 0, 0 is a point. Then 1, 1. Then for 2, root 2 is 1.4 or something. So somewhere out there, just a little above 1, and so on and so forth. So it will keep on moving like this. It will be increasing but at a decreasing rate, not like really increasing, not as steep. It will, the difference between the square roots shrinks slowly and slowly. So that's how a square root function will look like. So we've done reciprocal function, square root function. Now what about square function? A square function. What will be a square function? It will be essentially a relationship between real number to its square. So x squared. A function that associates any real number to its square, its own square, is actually a square function. So fx equals to x square. Fx equals to x square. That's what is a square function. Now, so it is a function from R to R, fx equals to x square. So just notice that domain of the square function is the complete real numbers, but what will be the range? Anything that is squared becomes positive, so the range will be 0 to infinity including 0, okay, closed at 0, so all positives and 0. So R plus essentially is the range. Now what will this function look like on the graph? So y equals to x square. Sounds like a parabola. So let's see how this comes out to be. So we have our axis. So now notice that whatsoever your x is, as I'm saying, the range is all positive. So only thing which will be required is the positive y axis. Okay, so whatever values come as output are positive. So your x can be 1, 2, 3, minus 1, minus 2, minus 3. Okay, let me take a bigger dimension here because we're talking about squares, 8 and so on. So for 1, it is 1, right? For minus 1 also, it's going to be 1. For 0, it is 0. For 2, it's going to be 4. For minus 2 again, it's going to be 4. And so on and so forth. So this is how the parabolic shape comes out. This is how the parabolic shape comes out. So parabola. Why? Because we are on the positive y-axis, whatever might be the x values. Okay, for positive x, for negative x, same number, the square will come out to be the same number. So for plus 2, minus 2, it's the same number that comes out, which is 4. Now try out on your own, what do you think would be a cubic function? We've done a square function. What will be a cube function? Cube function will associate each x to x cube. Okay, so just try to graph it out. What will it look like?